Hi, I'm Sihwa Park, a PhD candidate in Media Art and Technology at the University of California, Santa Barbara. My work on Symptom-Facing is a data-driven interactive audiovisual installation that tries to represent the stochastic nature of machine learning techniques and to raise concerns about the unintended use of machine learning with synthetic fake data. Symptom-Facing has three main components. First, t-SNE for dimensionality reduction. Second, face data including pre-generated fake face images and their face embeddings. Last, audiovisual representations based on metaball rendering and granular sound synthesis. In the real world, most machine learning problems involve high-dimensional data that has thousands or millions of features. Datasets with such high dimensions are subject to what is called as the curse of dimensionality that causes the issue of data sparsity. This makes training models inefficient and visualizing high-dimensional data difficult. This problem has pushed researchers to explore dimensionality reduction techniques. t-SNE is one of the most popular dimensionality reduction techniques for visualizing high-dimensional data in 2D or 3D space. Visualizing the data using t-SNE helps us to understand how our models are performing by revealing the clusters of the data. t-SNE is a stochastic process. It relies on probability distributions of data to prevent the crowding problem of data points. Uncertainty lies in this non-deterministic nature of t-SNE. The clusters of the data are meaningful, but their positions are not. Whenever you run t-SNE with the same dataset, it gives you a different result each time. Another aspect Symptom-Facing tries to represent is about the use of fake data generated from machine learning models. With advances in generative adversarial networks, it has become more feasible to generate synthetic data that is too realistic to be recognized as they are fake. Especially StyleGAN that generates fake faces is one of the remarkable examples. When the fake images are used in the real world, there would be several problems we need to think about. First, it would be getting harder to distinguish whether the images we are seeing are fake or not. In addition, the mixed use of real and fake data in facial recognition could be another problem. In the face recognition process, deep neural networks such as FaceNet are used for extracting face features or embeddings. A problem here is that such machine learning models are not designed to discriminate the fake input data. Symptom-Facing visualizes the real-time clustering of fake faces in 3D space by using t-SNE with 128 dimensional face embeddings of the face. As a result, similar faces are positioned close to each other. Symptom-Facing renders data points as metaballs textured with the face images. If more than two data points are getting closer, their faces begin to merge, creating a fragmented combined face. It also reflects an error value that t-SNE measures at each iteration as the jittery motion of data points. Symptom-Facing also sonifies the overall data distribution in 3D space based on granular sound synthesis technique. Symptom-Facing allows the audience to explore the data via a UI and to take a photo of their face to experience the piece. The audience can not only see their face being merged with fake faces in 3D space, but also check similar fake faces on the UI. Thank you.